Alright, so right triangle trigonometry. So we are going to have a right angle here. And so we already know that the side across from the right angle is the hypotenuse. But we will all abbreviate hypotenuse HYP. So that's going to be our standard abbreviation. And we know that we can use the Pythagorean theorem. If we have any two of these sides, we can use the Pythagorean theorem to find the third side. But we also want to be able to calculate angle measurements. We know this angle is 90 degrees, but what about the other angles? So there are ratios that exist in a right triangle. And the other two sides, the other two legs of the right triangle, are defined in relationship to the angle marked theta. So if theta is here, and I say if because theta could be either one of these angles. If theta is here, the side that's across from theta is called opposite. And we will abbreviate that OPP. And then this side that is next to theta, so notice it is forming the angle of theta, but it's not the hypotenuse. So the non-hypotenuse ray of angle theta is adjacent. The word adjacent means next to. And we will abbreviate that ADJ. And so there are there are three functions that relate this angle theta with the sides of the right triangle that you learned in geometry. And then there's three others that you guys probably don't know too much about. So we're going to start with what you know. You've probably heard of sine theta, S-I-N-E, sine theta. We will all abbreviate that S-I-N, sine of theta. Every function is going to get a three-letter abbreviation. And that is equal to the length of the opposite side divided by the length of the hypotenuse. And our second function is cosine theta. And we abbreviate that COS for cosine. And cosine of theta is equal to the adjacent side divided by the hypotenuse. And then we have tangent theta, which we abbreviate TAN, tangent theta. And tangent of theta equals opposite over adjacent. And you learn these in geometry, and in learning them, you probably are familiar with the acronym SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right. But each one of these functions has a reciprocal function. Not inverse. So when we talk about reciprocal functions, we're think about fractional numbers that are reciprocals. When you flip the numerator and the denominator, that's the reciprocal. When you multiply two reciprocals together, they equal 1. Now when you take the composite of a function and its inverse, remember that equals x, not 1. So we're looking at reciprocal functions, which is different than an inverse function. And so the reciprocal functions, the reciprocal for sine is cosecant. So cosecant of theta and we abbreviate it. Now we don't just start with the first 3 letters because that would be the same as cosine. So cosecant is abbreviated CSC, cosecant of theta. And that is equal to the length of the hypotenuse divided by the length of the opposite side. So look at your sine fraction and your cosecant. Do you see how they're reciprocals of one another? So the reciprocal of cosine is the secant function, secant of theta. We're going to abbreviate that SEC, secant of theta. And that is the reciprocal of the cosine. So that is the hypotenuse over the adjacent side. And then finally we have the reciprocal function for tangent is named cotangent. Cotangent of theta is abbreviated COT, cotangent theta, and that is equal to adjacent over opposite. So there are some people who like to look and say, well, I have to memorize these 6 things. And you could memorize the 6 things, but I think it builds a stronger relationship and then it's less to memorize. You memorize sine, cosine, and tangent, and then you just memorize which one is its reciprocal, and then you have all 6. Okay? Now, we also want to look at a special relationship between tangent and sine and cosine. So, let's look at the fact that tangent of theta, we know is equal to opposite over adjacent, right? We know that to be true. That's the definition for tangent. But what if I take sine of theta divided by cosine of theta? Well, sine of theta is opposite over hypotenuse. So that's my numerator. And then there's my major vinculum. And then cosine of theta is adjacent over hypotenuse. So I've got a complex fraction. Fractions within a fraction. I go back to what does it mean to divide? To divide means to multiply by the reciprocal of the denominator. So this would be equal to the numerator, opposite over hypotenuse, multiplied by the reciprocal of the denominator. So multiplied by hypotenuse over adjacent. Now, these came from the same triangle. So this hypotenuse and this hypotenuse, that's equivalent. So hypotenuse divided by hypotenuse is 1, right? So that just equals opposite over adjacent. So if tangent theta equals opposite over adjacent, and sine theta over cosine theta equals opposite over adjacent, then that must mean that the tangent of theta is equal to the ratio of sine theta over cosine theta. Alright, so I'm just kind of weighing in on you. Tell me how your knowledge with this orange part. Again, like I know, you should know this blue part from geometry. I'm hoping everybody feels pretty good about that. This orange part, brand new, totally new, never heard it before, heard it but never did problems with it. You learned it all already, somewhere, somehow. Tell me where you're at with the orange reciprocal functions. Let's see. Alright. Vaguely familiar for most of you. Either never heard it or sort of heard it. Declan's done some work with it before, but most of you have not. Alright. So we're going to do two problems together. Just two. But each problem has multiple parts. Alright, so for our first set of problems, we're going to have a right triangle here. Got a little more to scale. I don't like the way I drew this one, sorry. It's a little bit shorter. Looks more like that. And I say it looks more like that because this side is 8, and this side is 15, and so the way I was drawing it before, that was not going to look right. And this side is 17. And we want to give the exact values for all 6 trig functions. Now, if it says exact values, what it really means here is to leave these as fractions, right? Leave them as fractions. Simplify them if you can, naturally, but don't change them to decimal format. Because if you change it to a decimal and you round, then it is no longer an exact value. Alright, so my suggestion as you start these is that you start by labeling your sides. So across from the right angle is the hypotenuse. Oh, I forgot to put theta in here. This angle is theta. That's very important because if you don't know where theta is, you don't know which one is opposite and which one is adjacent. So across from theta is opposite, and next to theta here is adjacent. And you will work with these to the point where you don't have to label them anymore. And some of you may be grounded in this enough already that you don't feel you have to label every single time. But as we're starting this out, that's my suggestion. So sine of theta is opposite over hypotenuse. And again, you decide how long do you keep needing to write opposite over hypotenuse. Do you have to write that on every problem? No. But write it until you don't need to write it anymore. And so the opposite side is 8, and the hypotenuse is 17, and you're done. Do not turn that into a decimal. If you want an exact answer, you need to leave it as a fraction. Alright, cosine of theta is adjacent over hypotenuse, which is going to be 15 over 17. Done. Now let's make an observation here. Your hypotenuse is always your largest side, right? So when you have sine and cosine, you will always have a larger number on your denominator Therefore, your value will always be less than 1. Because you're always going to have a smaller numerator and a larger denominator, and so this number will be less than 1. It's going to be important as we continue working with this. Alright, then tangent of theta is opposite over adjacent. So that's going to be 8 over 15. Now, if this fraction could be simplified, like if it were 8 over 12 or something, or 9 over 15, we would simplify it. But we're not going to change it into a decimal. Alright, so then we're going to do our reciprocal functions. So cosecant of theta is hypotenuse over opposite, which is 17 over 8. Secant of theta, hypotenuse over adjacent, 17 over 15. Now let's make a similar observation here. On your cosecant and your secant, the hypotenuse is in the numerator. The hypotenuse is always the larger number. This ratio is always going to be greater than 1, because you're going to have a greater number over a smaller number. Then cotangent of theta is going to be adjacent over opposite, which will be 15 over 8. All right. Any questions so far? Alright, so our second example is going to be formatted a little bit differently. Some of you are like, oh my goodness, this is so easy. Don't ignore this second example. It's a little bit different. Still not very hard, but different. So in this example, you are told one piece of information. The cosine of theta is equal to 2/5. And then your job is to find exact values for the other 5 trig functions. So all you know is that the cosine of theta is 2/5, and you have to find all the other trig functions. So the first thing you want to do is you want to draw and label. So you want to create a right triangle. I don't know how you want to orient it. You want to make a right triangle. You want to put theta somewhere. And you want to label your sides. This is my hypotenuse, my adjacent, and my opposite. Now I know that the cosine of theta is adjacent over hypotenuse, and I know that that's 2/5. So on the adjacent, that's 2, and on hypotenuse, that's 5. Well, to do the other trig functions, we're going to need to know what that opposite side is, right? So to get the opposite side, we're going to do the Pythagorean theorem. So the next step is to find the opposite side. So the Pythagorean theorem we know is a squared plus b squared is equal to c squared. You can plug in your values and work it out step by step. But this is an honors class. You've been doing Pythagorean theorem for years now. Let's go ahead and manipulate this equation first. If I'm looking for a, isn't it true that a is going to be the square root of c squared minus b squared. Right? I'm going to plug in for b and c. I'm going to subtract b squared from both sides. I'm going to take the square root of both sides. I mean, you can do all that before you replace your numbers. So then a is equal to the square root of 5 squared minus 2 squared. 5 squared is 25, 2 squared is 4. A is equal, remember, mathematically, technically A is equal to plus or minus the square root of 21. We're not using the negative value because we're measuring a length, right? So that means the opposite side is the square root of 21. Now, if 21 had a perfect number as a factor, we would simplify that, but it doesn't, so we're just going to leave it as square root of 21. Remember, if we want exact values, we're not putting in any decimal approximations. Alright, so now we've got all of our sides, so now step 3, just go do all your other trig ratios. So we need sine of theta, that's opposite over hypotenuse, so that's square root of 21 over 5. Done. And then we need tangent of theta. That's opposite over adjacent. So that's square root of 21 over 2. Done. Alright, well then we need our inverse functions. Right? So we need cosecant of theta. That one's the inverse, not the inverse. My bad. That's the reciprocal of sine. So it's hypotenuse over opposite. So that's going to be 5 over the square root of 21. Alright, now here we have to do another thing before we box that answer. We're going to rationalize that denominator. So we want the denominator to be a rational number. Right now the denominator is an irrational number. So we're going to multiply by square root of 21 over square root of 21. And we're going to get 5 square root of 21 over 21. Now our denominator is a rational number. Alright, secant of theta. Secant is the reciprocal of cosine. It's hypotenuse over adjacent. So that's 5 over 2. Done. And then cotangent of theta is the reciprocal for tangent. So it's adjacent over opposite. So that's going to be 2 over the square root of 21. And so here's another one that we have to rationalize. So we're going to multiply by square root of 21 over square root of 21. So we're going to get 2 square root of 21 over 21. And if these came out to where we could simplify, like instead of 2, if this were a 3, we would simplify, because 3 over 21 would be 1 over 7, right? So if you can simplify fractions, you do that. But you're not changing any of these to decimals because we want exact answers.